Good evening to everyone. In the last video, I discussed about column chromatography basics and what is the principle behind this column chromatography, as well as what is going on this column chromatography, means how we are going to separate the mixture, that is A and B. Right. Now there we discussed a stationary phase which is made up of silica, slurry, and mobile phase. We took benzene as an example. Right. So now today's class we are going into the depth of the topic, that is uh, stationary phase. First we are going to discuss about the stationary phase. In the column chromatography, what is the stationary phase? Solid is the stationary phase. So for this, there are so many compounds are there. We can use them as a stationary phase. For example, silica gel, alumina, and Kieselguhr, similarly charcoal, etc. So many are there. Okay, we can use any one. But among these, silica gel as well as alumina are highly utilized by the in column chromatography as a stationary phase. Why? Because they are highly available in the market, and of course cost is very less. So here how we are preparing the stationary phase. Generally they either the silica gel or alumina you need to take, and first what we need to do, first that these two, or you need to convert them in the form of a powder, and then you need to add a little bit of organic solvent so that you are preparing a slurry. Means what? Here we are by the addition of solvent we are preparing a slurry. So this is used for wet packing method. After finishing of this stationary phase and mobile phase, I am going to discuss about this, what is meant by wet packing and dry packing clearly to you. So this slurry is used as a stationary phase in wet packing method, or sometimes you may use the powder directly. In such conditions we call it as a dry packing method. Right. So now we will see what is this silica gel. So what is this silica gel? Silica gel means which is SiO2 X H2O. SiO2 and XH2O means the surface is like this. Si, again Si, again Si, like this. So OH, similarly OH, similarly OH, like this. So SiO2 along with H2O. Generally, because of this presence of this hydroxyl groups, this silica gel is highly polar in nature. Highly polar in nature. Because of the presence of this hydroxyl groups, this silica gel is highly polar in nature. Now alumina. What is alumina? Even alumina is also Al2O3 X H2O, which is generally this silica gel G is used for at low temperatures, whereas this alumina can be used as a stationary phase by doing the experiment at higher temperatures also. Now the next question for us in our minds is that how can this A or B, depending upon their polarities, how they are going to adsorb to this stationary phase. See, last class I showed this diagram to you, right? So when B and A are introduced into this column, because B is more polar than A, B is more adsorbed to this stationary phase, whereas A will move quickly along with the mobile phase. How this B is adsorbing to this stationary phase means now we are going to study about the adsorption forces. What are those adsorption forces? First one is van der Waals forces, and second one is hydrogen bonding, and the third one is inductive effect. Among these three, or sometimes all these three, can act as adsorption, that is surface phenomenon between the stationary phase as well as the reaction mixture, either A or B. Generally, we know what is we know what are van der Waals forces. Generally, van der Waals forces are nothing but the intermolecular forces. Means generally some molecular attractions are there between different molecules, right? So these intermolecular forces will hold these non-polar molecules together with the liquid or solid state. Generally, those are physical in nature and does not involve in the chemical bond. When B is adsorbed to this stationary phase, B is just adsorbing onto the surface, but it is not at all reacting chemically with this slurry. That is the main point we need to remember in our minds. These van der Waals forces or hydrogen bonding or inductive effects, all these are physical in nature. Means those are not reacting chemically with the slurry or silica gel. I'll show what is how this hydrogen bonding occurs. See, if you observe here, there is a functional group like keto group RO. How this hydroxyl groups are connected to this one. See, H is connected to oxygen, and again H is connected to this oxygen. Oxygen is connected to this H. Like this, hydrogen bonding is the cause for the adsorption here. Hydrogen bonding is the cause between this silica gel as well as this organic compound. And still one more is also there. What is that one? That is inductive effect. Generally, if our reaction mixture contains functional groups like ketone group or nitro group, like that, in such conditions these heteroatoms like nitrogen, chlorine, oxygen, these heteroatoms obviously a dipole will be created. Because of that it adsorbs onto the stationary phase. So finally what we need to place in our minds is that the cause for this adsorption is maybe van der Waals forces, or maybe hydrogen bonding, or maybe inductive effect. So that's it about the story behind this stationary phase. And next one, what is the next one? Mobile phase. The mobile phase is also called as what? Eluent. Eluent. Depending upon their polar nature, there is a series of solvents, that is hexane, cyclohexane, benzene, and next one is methylene chloride, chloroform, and acetone, and ethyl alcohol, and the next methyl alcohol, and next one is water, like this. When you are coming from top to down, its polar nature increases. Polar nature increases. So depending upon their polar nature, these eluents are placed in a table. This we are calling it as elutotropic series. Elutotropic series means these solvents what we are using as a mobile phase in column chromatography are arranged in a particular table depending upon their polar nature. Means among these hexane is non-polar, and when you are coming from top to down its polar nature increases. So the mobile phase what we are using is called eluent, and the arrangement of these depending upon their polar nature is called allotropic series. Generally in column chromatography, the selection of solvent, that is mobile phase, generally first you need to prefer non-polar solvent. Later on you can increase this polarity, means here the diagram I will show you. See here, after this reaction mixture entering into this column, what you are pouring finally, you are pouring from the beaker, that is what eluent you are pouring. Initially, you need to take hexane, let us suppose 10 ml of hexane you need to take, which is non-polar. Let us suppose uh, which is not separating A and B quickly. In such conditions, the polar nature you need to increase. Eluent's polar nature you need to increase. Means you need to take hexane 9 ml and add 1 ml water. Means its polar nature is increased, isn't it? Not directly water. First you take what is this CHCl3, and later on still the separation is not fast. Such conditions take 8 ml and add CHCl3 2 ml. Like this, the polar nature of this eluent you need to increase, so that this separation of A and B will also increases. So that is the story behind this mobile phase. Once again I am telling, mobile phase is a selection is organic solvent we need to take, also called as eluent, and different organic solvents are there depending upon their polar natures. We are placing in the form of a table which we call it as allotropic series. Initially the selection of solvent should be non-polar. If the separation is not quick, if the separation is not going fast, in such conditions the polar nature of this organic phase we need to increase, like in the form of 10:2 or 9:1, like that ratio, right? And in the last video I told to you, depending upon their polar natures the adsorption capacity depends, and so that A and B will get separated, right? Now we will see what is about this dry packing method as well as wet packing method. Now wet packing method. The wet packing method is nothing but the same column chromatography what we are discussing till now. In this column, at the down what we are placing, cotton we are placing. Initially we need to pour benzene. We need to pour benzene, means the organic solvent or mobile phase what we are taking. Just we are just pouring that one, and later on you place this silica gel slurry. While you are pouring this silica gel slurry into this column, you need to open this tap here, so that benzene slowly, so that this benzene will come down, and this silica gel is placed in the column uniformly. That is very important. No lumps should be there while you are pouring this silica gel slurry into this column. If any lump or bubbles are coming, in such conditions adsorption is not even, right? Uneven అయిపోతుంది. So that's why we are pouring benzene first, and when we are starting pouring this silica gel into this column, you need to on this tap, so that benzene again we are collecting. In such conditions this silica gel slurry can place in this column evenly. Okay, and the next what we are going to separate here, let us suppose I want to separate orthonitroaniline as well as para-nitroaniline. I want to separate. So I am pouring these two reaction mixtures into this column, and later on a benzene is poured, that is eluent we are pouring from top of this column. So this orthonitroaniline is orange in color and para-nitroaniline is yellow in color. So we will observe this differences clearly in the column. This orthonitroaniline is less polar, so that's why it will move quickly. It will move quickly, so that which is collected in the conical flasks first. And this para-nitroaniline is more polar in nature, that is its adsorption capacity is more, so that this yellow color para-nitroaniline run down slowly. So after 5 to 10 minutes of time, you will observe two different colors, yellow at the top and orange at the bottom. Means first we are going to collect orange color orthonitroaniline, and then we are going to collect this yellow color para-nitroaniline, right? Later on those two can be separated from benzene very easily. Okay. uh, right. So then next, what is our main thing? It means wet packing method means we are preparing silica gel slurry. Means first we are taking silica gel and made it in the form of powder, and by adding benzene or suitable organic solvent we are uh, doing that in the form of a semi-liquid paste, and that semi-liquid paste is transferring into the column. You need to wait for 10 to 15 minutes of time, so that that column will become dry. Okay, so that is the main thing happening in this wet packing method. Now coming to this dry packing method, there is a slight difference between these two methods. In the dry packing method, that silica gel powder is taking directly. Silica gel is poured into the column directly. There is no addition of any organic solvent, no need to prepare slurry, everything. So the main difference is these two reaction mixtures, what we want to separate. Generally what we are adding organic solvent. Here the organic solvent is CHCl3, that is chloroform, is added to this silica gel. I will explain clearly to you. So this dry packing method in column chromatography, what we are doing. So silica gel powder placed directly into the column. Place it directly into the column. Now we need to add that reaction mixture, right? So first the reaction mixture is added to the suitable organic solvent, that is CHCl3 here, and this silica gel is also added. This powder is also added here. Means take a beaker, add this A plus B and this solvent, organic solvent, and little bit of silica gel powder. After some time what will happen, you need to made in the form of a paste. You need to do in the form of a paste. Later on, by leaving that for some time, this organic solvent will get vaporized. Because it is volatile in nature, it will get vaporized. So finally what is remaining here, this silica gel as well as A plus B. These A plus B, that reaction mixture is adsorbed to this silica gel powder. Now this powder is poured into the column. Already this column has what? Already this column has powdered. Already this column has what? Powder form of silica gel. Now I am adding the same powder. I am adding the powder. What is this powder? A plus B, which is adsorbed on silica gel. Means this we are placing here. Now on top of it you need to pour this eluent continuously. So again the same thing will happen here. among this A plus B, because B is more polar, which gets more adsorbed to this silica gel, so that B will run down slowly, because A is more non-polar, which adsorbs less with this silica gel, so that A will come quickly along with this eluent. So the main difference between the dry packing and wet packing is that in the wet packing we are made silica in the form of slurry, but here the powder directly we are entering into the column. But here the reaction mixture along with this organic solvent we are not placing directly. We, for that mixture we are adding some silica gel powder, so that after some time this solvent will get vaporized. These A and B will get adsorbed to this silica powder. This total will become powder now. The same powder we are pouring here, and the eluent is introduced into this column depending upon their adsorption strengths. The same experiment if we conduct here, orthonitroaniline will come down quickly. Later this para-nitroaniline will come next. Okay, so up to this we completed this column chromatography. In my next video I'll discuss about the TLC, that is thin layer chromatography.